Welcome to your video on polynomials, their x-intercepts, roots, factored forms, and what their degrees tell us. So let's first start by defining a polynomial. You might have heard this in other math classes. And what I'm going to go through right now is kind of the informal definition just to build up to it. So note that a monomial is an expression with one term. So 2x is a monomial. 4x squared is a monomial. A binomial would be an expression with two terms in it, so x plus 4 is a binomial. 2x minus 3x squared is a binomial. You have two terms. Then there's a trinomial, an expression with three terms in it. And we don't really have names for one with four terms, but everything after that we just call a polynomial. So a polynomial is an expression with many terms. Poly meaning many, so many terms. To the more formal definition, a polynomial is an expression that looks like this, where we have coefficients and degrees. A couple things to note here is that the exponents of a polynomial are always whole numbers, either 0, 1, 2, 3, 4, something like that. And the coefficients have to be real numbers. So here is an example of a polynomial function. So polynomial function being that we have it set equal to y. It's two variables here. And we always put the highest degree term at the front. This leads the way. It's just how it's done. This is easy to the reader to see that this is a fourth degree polynomial, and that's what we call this, is a fourth degree polynomial. Polynomial functions also have coefficients, right? The number in front of the variable is called the coefficient. And note that if it's not written, it's considered 1. And I put in a 1 here, but I didn't have to because it's just implied that there's 1x to the fourth there. We call this little guy on the end the constant term. So if there is just a number added to the end, it is called the constant term versus the coefficient. So that's a polynomial function. So in general, you have the general form of a polynomial. And to ease into polynomials, I'd like to first look at cubics. This is kind of the nice way to start looking at higher degree polynomials. We started with quadratics last section. Now we're going to move into cubics. So here's the general form of a cubic. And here's the factored form of a cubic. A few really important notes here. The degree of a polynomial tells us how many factors are in the factored form and how many roots the polynomial has. So the degree of the polynomial tells you how many factors are in factored form, and thereby telling us how many roots the cubic has. Super, super important. Another thing to note here is that this also tells us how many x-intercepts the polynomial could have. So this graph, this cubic, has a third degree, it has three factors, it has three roots, and it could have up to 3 x-intercepts. The next video and in 2 classes from now, we'll explore kind of when you don't have 3 x-intercepts, what happens with a cubic. But don't worry about that for now. So real quick, your multiple choice question for the quiz. A polynomial with the highest degree of 5 has how many roots? Is it A1, B3, C5, D7, or E? I got clever. 5 roots and up to 5 x-intercepts. And the correct answers are both C and E. C and E. Okay. Here's an example of a problem that I might give you in class to practice these concepts on a quiz, on a test. I might give you a graph and ask you to write the cubic function for the graph below. Some clues that will help you along the way is we've now learned the cubic is a third degree polynomial, which could have 3 x-intercepts and 3 factors. So here are my x-intercepts for both graphs, and I immediately notice that the graph on the left and the graph on the right have the same x-intercepts, but they're obviously different graphs. So that means they're going to have different equations. So we got to do a little bit, one thing's going to be different about their equations. But they're both, we're going to start out with factored form of a cubic. Here we have factored form of a cubic. We have 3 roots, 3 factors. So we know that for both graphs, we're just going to plug in the roots. We have an x-intercept, a root of negative 2.5, so that's going to be x plus 2.5. We have another x-intercept, or root, of 3.2, so that's going to be x minus 3.2. And the final factor for our factored form of a cubic, the root is positive 7.5, so the factor is going to be x minus 7.5. I hope you're picking up on my vocabulary here. We call this an x-intercept. This would be called a root. This down here, x plus 2.5, is the factor. X minus 3.2 is a factor. So there are 3 factors, 3 roots. So now, here's where we've got to kind of diverge. And we're going to notice that both graphs give us these extra points, the y-intercepts, which are really handy. And I'm just going to focus on this graph on the left first and plug in that point for x and y. With a little simplification and solving, I get the a equals 4. So therefore, the equation of this graph is what you see here on the screen, y equals 4, and then times the 3 factors. So this is the equation for this graph. When I found that equation, I used this point on the curve, on the cubic. So now what we're going to do to find the equation for this graph on the right is to use its 4th point. So what I'd like you to do is pause the video and plug this point into the factored form that you see on the screen, y equals a times x plus 2.5, etc., and solve for a, and give me the equation of this polynomial. I gave you the one on the left, now you give me the one on the right. Okay, last thing on the video, and then we'll have lots of practice with this in class tomorrow. I'm going to ask questions of you to use the graph of a polynomial to find the factored form. So actually this question isn't written, I apologize. It should say, use the graph of y equals 4x cubed plus 8x squared minus 36x minus 72 to find the factored form. The steps to do this are, number 1, you're going to graph the function in your graphing calculator. Step 2 is use second calc to find the zeros of the graph and write those down. Then put those zeros, or roots, into factored form of a cubic, right? So those are the roots, put them into factored form. Note that the leading coefficient from the general form is a equals 4, right? Up here, the leading coefficient is a equals 4, so that's going to go right into the factored form, and you should be done. This is the final question on the quiz. Hope you ask really good questions and come to class prepared to practice these concepts. Factored forms of polynomials and how to find them.